You know, when we talk about the AI revolution, what are we really talking about? It's not just some abstract idea floating around in the cloud. Nope, it's a real high-stakes battle being fought line by line in code. This is the story of the powerful engines that are driving AI, the fierce rivalry behind them, and how that fight is literally changing our world.
All right, so here's the game plan. We're going to start with the two titans of the AI coding world. Then we'll dig into what makes them so different, their core philosophies. We'll even see who wins in a head-to-head race. After that, we're going to zoom out and look at the amazing things they're building, talk about the whole generative AI explosion, and wrap up with where you might fit into all this.
So right at the heart of pretty much all modern AI development, you've got this clash of titans. On one side, you have PyTorch, which is backed by Meta, and on the other, you've got TensorFlow, the powerhouse that comes from Google. And these aren't just, simple programming tools. They're entire ecosystems, really, and they represent two very different philosophies for building intelligence.
But what exactly are these things? Well, think of them as the engine room of AI. They're these super sophisticated software libraries called frameworks, and they give developers all the fundamental building blocks, the code, the tools, everything that lets them create anything from ChatGPT to self-driving cars.
And here is the battleground, laid out plain and simple. Just look at this. On the one hand, you've got PyTorch. It is the undisputed king of academic research. We're talking like 80% of research papers mention it. But then, on the other hand, you have TensorFlow, with this absolutely massive historical footprint. Over 170,000 stars on GitHub. That tells you just how huge its developer community has been over the years. So you've got the darling of the research world versus the established industry giant.
So, why the big split? Why does research love one and industry historically use the other? Well, it all comes down to their core design philosophies. And this isn't just about popularity, it's about two fundamentally different ways of thinking about how to build AI. It really is the researcher versus the powerhouse.
Okay, take a look at this. This is a basic training loop in PyTorch. Now, if you know any Python at all, this probably looks super familiar. It's clean, it's intuitive, it feels like you're in control of every single step. And that's exactly why researchers love it. It's incredibly flexible, perfect for trying out new, wild, unconventional ideas.
Now, let's contrast that with TensorFlow. This manual loop here, it's a bit more explicit, right? A little more wordy. You've got this gradient tape thing you have to use to keep track of everything. It just feels more structured, and that's totally intentional. This whole structure is designed for building really robust, scalable systems that can be deployed to millions of people without breaking.
So here's a really simple way to think about them. PyTorch is the researcher. It's flexible, it feels more like just writing Python, and it's usually easier to figure out what's going wrong when you're debugging. TensorFlow, on the other hand, is the powerhouse. It's built for scale, and it has this incredibly mature set of tools for getting your models onto phones or running in a web browser, places where it's historically been king.
And listen, this isn't just some abstract idea. Developers feel this difference every single day. As one developer on Reddit put it so perfectly, research uses PyTorch because it's just plain easier to build weird new things, which, that's the whole point of research, right?
Okay, so we know they have different philosophies. But how do they actually stack up when the rubber meets the road? When you put them to the test, who's faster? Let's look at the data.
First up, let's talk training time. So in this test, researchers were training a really complex model. And look at the results. PyTorch got the job done in just under 17 hours. TensorFlow, almost 22 hours. That's a 5-hour difference. When you're working on these monster models, 5 hours is an eternity. That is a huge advantage for PyTorch. But what about inference? That's just a fancy word for how fast the model can make a prediction after it's trained. And this is critical for any real-time app. On small images, the difference is just staggering. Look at that. PyTorch is nearly 3 times faster. For an app that needs to give you an answer right now, that kind of speed is a total game changer.
But it's not always that simple. Check this out. When the researchers switched to bigger, heavier images, that performance gap got a whole lot smaller. PyTorch is still faster in this particular test, but not by that massive 3x margin we saw before. It just goes to show you performance really depends on the specific job you're trying to do.
So, what's the final verdict here? Well, there isn't one single winner. For quickly building and testing new ideas, for research, PyTorch often has a clear edge in both how easy it is to use and how fast it runs. But if you need to deploy a model at massive scale across tons of different devices, TensorFlow's mature ecosystem is still a beast. At the end of the day, the best tool is always the one that fits the job.
Okay, so we've been deep in the engine room, right? Let's zoom out. What are these frameworks actually building out there in the real world? This is where all that code starts to change lives.
And the impact is just profound, especially in healthcare. These are the tools powering algorithms that can diagnose skin cancer as accurately as a top dermatologist, or that can dramatically speed up drug discovery, potentially saving years of critical research. It's incredible.
And this isn't about replacing doctors. It's about making them superheroes. Look at this pathology workflow. An AI model scans the slide, does a first-pass analysis, and then flags the most critical areas for a human pathologist to review. This kind of partnership makes things faster, reduces errors, and lets the human expert focus their skills where they're needed most.
And you're seeing the exact same kind of transformation happening in the business world. AI is democratizing data, letting a marketing person ask really complex questions just using plain English. At the same time, it's helping optimize these massive global supply chains by predicting bottlenecks before they even happen.
So all of this hard work, all the research, the code, the real-world applications, it's all been building towards something massive. And that's the generative AI boom that we are all living through right now. These tools lit the fuse, and it's brought us incredible progress and some really tough problems.
This timeline just shows how fast things have exploded. In 2017, a research paper introduced something called the transformer architecture. That's the key idea behind almost all of today's models. Just 4 years later, we had mind-blowing text-to-image models. 1 year after that, ChatGPT put a powerful AI in everyone's pocket. And now, in 2024, text-to-video models are creating clips that are almost impossible to tell from reality. The pace is just breathtaking.
But all this incredible power is forcing us to ask some of the hardest questions we've ever had to face as a society. What happens to jobs when something like creativity can be automated? How do we fight misinformation in a world of convincing deepfakes? These aren't just thought experiments anymore. They are urgent, real-world challenges for every single one of us.
So, after all of this, the code, the data, the massive societal shifts, it's pretty easy to feel like you're just watching from the sidelines. But the story of AI isn't just something that's happening to us. It's something we can all be a part of.
And for anyone out there who's feeling inspired to jump in, the path forward is actually clearer than it's ever been. It's a journey, for sure. It starts with a solid foundation in Python, moves through the core ideas of machine learning, and then leads to specializing in the exact fields that are exploding today. It's definitely challenging, but it is an achievable path.
So we've seen the powerful tools like PyTorch and TensorFlow that are literally building the future. We've seen the incredible things they can do and the really tough challenges they bring up. The tools are more accessible than ever before, and the path to learn them is laid out. So the only question left really is, how will you choose to shape the future of intelligence?